Thank you all for coming. This is Charlie, and I'm Justin. So here we are from the analytics platform team. And this day we would like to talk to you about building data products and tools, and specifically about Data Hub. So on this presentation, we'll first go through an overview of why we are building this product called Data Hub. Then we'll go into an in-depth look in terms of the architecture and how we went about to building this. And lastly, we'll go just talk about some of the learnings that we thought could be interesting to share from this project. So first, in terms of the overview. So this is a very coarse simplification of how data flows at Pinterest. But just to give you guys an idea, so initially, and by data, this means like everything that users do and interact with on our client apps. So, for example, like every time that you may open a pin or may like save a pin and so on, this creates events, this creates actions. So this says like user X did this action on this time. So all of these actions get sent or will get batched up and then get sent over to our API servers. And then these API servers store these events in local disk, just so that it's fast. And then another process that runs continuously along with the main server process. Basically, you just reads this file from disk and then sends it over to Kafka. So this process, we call it Singer. And once it reaches Kafka, we have another downstream consumer, which basically does like very basic or like core sanitization, which is like deduping the logs, checking that they're like basically like consistency, non-corruption, all those kind of things. Once that's done, it gets sent through Merced over or persisted through Merced over to S3. And basically, this just generates the raw events, main tables of Pinterest. After these tables are in S3, we have many jobs, basically like Hadoop and Hive and cascading jobs that read this data and then transform it into other forms or into other tables. So you can imagine that there's like thousands of tables, like literally tens of thousands of tables that get created. And the reason for this is because these are different joins or different ways to consume this data, prepare it for downstream consumers. Then basically we just call this like derived data along the way. And the output of this, or like the reason that we do all of these transformations, there's many reasons, but like the main use cases is to be able to, for example, like support ad hoc querying. So being able to have visibility into our system and say like, hey, how many users do we have at the very basic form? Or like, hey, what is the propensity of someone to click on this pin given this surface that it appeared on? Basically, running ad hoc queries is just like writing a kind of like SQL statement that can be done by Hive, Presto, or similar languages. Another consumer is machine learning. So this means like every time that, for example, you open the app and then you get like recommendations on your home feed or you read recommendations on like search and all of these kind of things. These are based on like machine learning models that are trained based on this data. So every day there's a new training instance going on. I mean, different teams for their own purposes, but they just train on the new data, for example. Do you also have like other like use case? For example, like Analytics, it's a tool we built on the analytics platform team as well. So it's a simple tool to be able to chart and dashboard key business metrics. And Experimenter is our A/B testing management portal. So basically, you can go into this tool to create experiments. We call experiments basically A/B tests. So to create experiments, run them, manage them, and then like see the results. It's also another tool that we built in the analytics platform team. In this talk, we'll be focusing on one of these main use cases, which is basically ad hoc querying. So for ad hoc querying, we have had many different solutions across the time in Pinterest history. These are the main tools that we have had in the past. So we started, of course, like this was like 5-6 years ago when Pinterest started to have a lot of data. We started to have to use command line and MySQL. Of course, at some point in time, this didn't scale. like basically like analysts and like even engineers and so on, we were like hitting the basically like the database so much that like it started to become a problem. Then after that, we moved to Redshift from Amazon, and we moved to a tool that you downloaded called SQL Bench. So it's just like a UI you download to your Mac to be able to issue queries more easily. This also ran into some problems in terms of scalability when we had like a lot of data later on in time. And so we moved to another service, in this case, like a hosted service called Qubole. So basically, they both provide a UI, and they also provide their own cluster of Hadoop machines. So you can like run ad hoc queries on top of that. And after that was done, we started building our own in-Hive, Hive and Presto. So these are like internal clusters that didn't have any UI, but just like were able to accept queries. So we needed a UI for this. So in this case, we went with another third-party solution called Alation, and they provide both kind of like say a UI to connect any custom querying that you may have, like in our case, like our in-house Hive and so on, and also provides a lot of like data cataloging solutions. So data catalog, by that we mean being able to store and list what are your tables, be able to document them, be able to share them, kind of like say understand what is behind a given table. So some of the bottlenecks that we had with the existing solutions were the following. In terms of Qubole, it had many pros, like it was awesome at sharing and it had a very simple UI. So people really liked this aspect. But it has some like difficulties. So for example, like it was difficult to organize queries. So people, even though it had a saved query feature, like most people like that we asked, like, hey, have you used this feature? Most people just said no, and they were saving their own queries into their own like notepad files and so on. It was also not very good at data cataloging features, so it was not very advanced in this regard. So it had like at that point in time, it hadn't built a lot of like features that we were looking for at that moment. So after we moved from Qubole to Alation, it also had a lot of like great things. So for Alation, is really great at being a data catalog. So it provides a lot of very advanced functionality to search, for example, your data. But aside from this aspect, when we talked to users, we found that after you use it for a long time, the UI was getting like slow. The reason is because people were all keeping their tabs open within Alation, within the system or within the UI itself, and that caused a lot of memory usage within Chrome. People were using it this way because like of the lack of like other ways to save or store these queries. Even though it did have like a saving query feature, also people were not able to use it easily to be able to use it often. And then it has some stability issues, at least for us, near the end of the life where we had a lot of concurrent users, at least within Pinterest. At least our integration was like basically crashing almost every day. And like had some other UI caveats, like viewing and downloading was not very important, not very easy. And it didn't have an integration with our in-house Hive logs, which may be a matter of our integration, but still it made it difficult for our users, and it also was difficult to cancel queries. So these are all like small details in some part, but just make the users' life a little bit difficult. Regardless of that, even though these solutions have like many very good characteristics, a very important part of this was that there were many specific needs to Pinterest itself that didn't make sense for these external vendors to implement. So for example, we have an internal concept called golden tables. So it was not very easy for us, for example, to modify their UI so that like these golden tables would be easily findable in their system. Like we would have, we tried, but there were some workarounds that we needed to do, and it was not an awesome solution. Another example is like integrating data lineage. Even though Alation does provide support for data lineage, we hadn't been able to integrate it to our systems, at least like after like several months of like existence of this product. Another example is to be able to integrate with our internal workflow systems. So for example, like show which query generated a given table. Of course, like as an internal solution, we are more able to do that more easily than rather than like integrating to a third party. So even even though we had like a lot of positive things, we opted for to try out building an internal solution. We call this solution Data Hub. So basically, what Data Hub is a UI, like a tool, where you can go in and then you can run queries. And you can also explore the data and the metadata of this data. So that means like being able to document your tables, being able to share them easily with other people, and this kind of like just normal process of such a tool. Charlie will talk more about in depth of what Data Hub is, how we build it. But just to first talk about the results or the impact of what Data Hub had. This is the graph of Data Hub adoption over time. We see the number of queries of Data Hub on red and the number of queries of Alation on blue. So we see the transition period around March of this year. So it has been out at least a couple of months now. And what's more important than, say, the number of queries, or at least from our side, is this user satisfaction from our actual users using these products, right? So in terms of the Qball, when we ran our survey, 32 votes we came in. We had a 6.8 like score for this tool. We had a 6.2 score for Alation, and we had a 8.1 score for Data Hub. So, I mean, basically, we were very happy with the results because, I mean, that was one of the metrics that we cared the most about. Then, in terms of increased usage, after rolling out Data Hub, it increased the number of, or the percentage of PMs running ad hoc queries from 40% to 60%, and in terms of engineers from 40% to 51%. And I mean, to get just like an idea of how many users we have, right now we have like 660 WAUs, so within the company, these are engineers and PMs. And now Charlie will talk more about how we build it from the product and tech aspect.
All right, we'll start with actual Data Hub demo. And oh.
You may want to skip.
Oh. Ooh. Oh.
Yeah. Oh, cool.
Oh, I think I have two screens open. Yeah. Oh no, I can't get to that screen right now. Let me just. Okay. All right. So this is Data Hub, and for Data Hub, there are two parts, two main parts of it. Data docs. This is where you actually write queries, and tables, where you view metadata about Hive tables and such. And so I will talk about data docs first. So what exactly is a data doc? So you can think about a data doc as a notebook where you can write queries and write analysis about a given topic you want to research on. So for any data doc, you can create a query cell. This is where you can run queries against. We support Hive and Hive Server 2 and Presto, and a text cell which really support like things like rich text editing, so you can write any analysis you want here. And let me show you what writing a query is like. So we have things like auto suggestion built with Data Hub. What? Oh, there's a. Oh yeah. Well, I don't know why it's not working. but this is all the suggestions powered by Elasticsearch, and we also have, like, if you hover over things, we can actually show you the function definitions from that we scraped from Hive and Presto. If you hover over any tables, we can we have a built-in parser that kind of like figure out where the tables are, and then it will show you things like table descriptions, partition of the table, columns, and S3 locations. And okay, well, without further ado, let's actually run it. And So, I'm sorry, but like when you're running the query, sorry, I have to keep Slack open because I'm going to show you something in Slack. But while you're running the query, you will get live results and logs and progress from Hive. This is streamed through Socket.io. And sometimes Hive query takes 4 or 5 hours to finish, so you can actually do a notify me here, and we will send you a Slack message or email once it finishes. Well, this query probably would take a bit more time, so we can look at things. We can move on to query engines. So before we build something like a query engine, when our backend goes wrong or when user is using way too much resources, their query gets throttled, but they don't really understand why why does their query get throttled. So we build this engine status page to provide insight into that. And what essentially it does is it will show you how much resource your query is consuming. Also, it shows you for Hive, it will show you how much resource is allocated to you and how much resource are you consuming. So to see whether or not why we're throttling your queries or why is your query not running. And for Presto, actually our Presto is not working right now. My query just finished. So it will send me a message on Slack and I can click on the link to go back to the query. And I'll just close Slack right now. And once after we build this engine status page, we receive a lot less questions from people because usually our message will tell people what to do. And yeah, as you can see, it used to be green because I was running a query. Now it's blue because the query hasn't finished. And once it's finished, you can export the results into CSV, TSV, or things you can insert it to an IPython notebook. So this generates Python code for you to download, to just download it into Python. And also we support exporting data to our internal in-house tools. And so now let me show you one of the data doc written by our data scientists. As you can see, not only we can show tabular data, we also allow time series charting within Data Hub, and also I think this data scientist also write down an analysis for to share with other people. And sharing on Data Hub is also very easy. You can share any cell directly just by clicking on a cell to copy, or you can just copy a URL and share with some people. And so that's all for data docs part. And now let's move to the data table part. So this table I'm going to show you is actually the users table at Pinterest. And as you can see, it's a pretty important table because we can see that it's viewed by about 255 people. And on tables like these, we can actually add any description. Well, at Pinterest, we don't add that many descriptions, so I just added this. I just added this pretty random description. And you can also see all the data docs that actually reference this table. And you can also see just any metadata you have we fetch from Hive Metastore. And similarly for columns, you can see all the columns, all the types, and you can also give a description about the columns in Data Hub. And row samples, basically, what row samples does is that we will just front end will fetch 100 rows from that table and show you the sample rows directly in Data Hub. So before you actually run a complicated query, you can see what kind of data is in this table. And the lineage. So basically, we put listeners on our data jobs, and it allows us to compute what tables actually is derived from this table. And you can see here, since this is the users table, it has a lot of tables that's derived from this users table. And for some of the tables, you can actually see which which data job that actually generated this table, and also the query that generated this table. And that's all for the Data Hub demo. Now I will talk about how we actually implemented Data Hub. So it's pretty easy. We don't have that much stuff. So for the front end, it's a React Redux app, and we use Colmere for our query cells. So that powers our auto completion, syntax highlighting, parsing, and tooltips and linting as well. And for the rich text, we use Facebook's Draft.js, and it's a pretty good library. And we use Socket.io to stream live Hive logs, Presto progress to the front end. And the back end, we use Python. That's just because Python is a pretty popular language at Pinterest, and we have our server is written in Flask because Flask is a very simple, easy to use server, and we use SQL Alchemy as our ORM for MySQL. And when we actually run queries on Data Hub, it's actually not running on the server because queries take forever to run. So we have we use an async task queue, and we use Celery, and we also use Elasticsearch to power things like searching tables, searching data docs, and for table auto completion. So for our store, it's we use MySQL to store our most important data, like data doc definitions, table metadata about table, and we use S3 to store query results because sometimes people query for gigabytes of data, and it will just destroy our MySQL database. Bless you. And we use Redis to store live data. So for example, we use it as a Celery broker. So anytime we issue a Celery task, it actually goes through Redis. And we also use Redis to achieve multi-machine Socket.io. And our deployment, it's just the standard. All the servers are wrapped in Docker, and we use the Pinterest deployment tool called Teletran. So we have some Teletran script that makes sure it's very easy to deploy on Teletran. So yeah, all these are open source technologies. Next up, I'll just go over what happens when you run a query on Data Hub. So when I click on the red Run button, what happens is that it will hit our Flask endpoint, and the Flask endpoint would create a MySQL role, and it also issue a Celery task and sends it to Redis. And what happens after is that it will respond to the front end saying your query has been initialized, and then the front end will send another request to subscribe to Socket.io and subscribe to a room that's specific to this query execution. Meanwhile, the Celery backend worker would pick up the task from Redis, and you will talk to Hive Server 2 or Presto to actually run the query. And it will then pull any results, any logs, any progress, and send it through Redis and Redis Socket.io, which gets sent to the front-end server, front-end browser. And while polling, if there's an error happen or the query finishes, you will update the state to MySQL to actually finish it. And once the actual query is finished, it will fetch the results in a 10, 20 megabyte chunk at a time, and then upload chunk by chunk to S3. And then it will do one last update to Socket.io telling the browser that the query is finished, so the result will show up on your browser. And next up, I just want to talk a bit about how security works on Data Hub. So originally, we designed Data Hub so that it's open to anyone. So one of the issues we've seen with previous tools is that when you're sharing things with other people, you often have to click on a bunch of permission stuff to make sure it's make sure it's shareable with other people. Whereas Data Hub, you just need to you just copy the URL and paste it to people. So there's no going back and forth. But then the issue arises where we want to also be able to run PII queries, and PII queries is only allowed to be accessed by a certain group of people who has permissions. So what we did is that we tagged each backend you run with a permission value, which is a bitwise value that's derived by which which LDAP group you're actually in, and every time you run a query, the query gets tagged with this bound with this permission value, and then the Datadog will get will perform a bitwise OR on all the query it has to compute its permission. So to view a Datadog, you need to be able to view any query executions. And then when the Chrome, when the browser requests the data, we'll generate a user permission and then just do a bitwise, and then we filter out any permission that the user cannot access, or return a 503 if they request that resource directly. And last thing I'll talk about is our live search structure. So on Data Hub, if you edit any Datadogs or edit any table descriptions, those things get propagated into our Elasticsearch immediately. And what we have done is that every time you do an update, the request updates MySQL role, which we have set up SQL Alchemy triggers, and those triggers would write a dirty entry into another table, and we have workers that pose on this dirty entry table, and then you will read from MySQL and update the Elasticsearch directly. We also have a cron job set up on that worker to update to pull data from High Metastore daily and update it into Elasticsearch as well. So that's everything for Data Hub demo and its architecture. Now Justin's going to talk about what things we learned while making Data Hub.
So these are the main things that we learned from this project. So they're probably very basic, but we found them very, very important actually from the project itself. So basically, the first one is like just talking to users. So we found this that like as soon as you start a project, you probably want to start like talking to users to get like feedback whether the project even makes sense to them. Is it like addressing the main pain points that they currently have? Is there anything that you may be missing? And an important part of this is understanding how they already work. So, for example, like after talking and then like with users about like, hey, we're thinking about doing this thing called Data Hub and so on. Basically, we asked them like, how do they currently work? And we found that our users really like were storing their queries into their own notepads, into their own Evernotes, and like say Apple Notes and so on, just because it was the easiest way to just store the queries. And the problem was that then these queries were only found by them, but they were not easily shared to other people, or people could not share or find them. Even though these other tools that we had provided some functionality of storing queries, and they were not being used by our users. So after we understood a little bit better how do they currently work, basically we tried to move the current workflow. Like how can we make a product that actually works the way that they already are working? So basically that's why we went with the notebook approach. So this is a bit similar to like what Jupyter is doing. So Jupyter has a similar notebook approach, but we tried to make the look and feel and like basically how it worked to be as close as possible to say an Evernote and to a Notepad, like a plain dumb Evernote kind of thing, rather than like feel like a tool. In order for it to be this goes into the second part, which is like being very simple and not intimidating. So we try to make it as not intimidating to new users as possible. So like say there's a lot of casual users that are maybe trying out their first queries for the first time, and we want to onboard them into like actually running queries because they may not be used to doing this. And around this, one of the things that we, learn, at least because we are not designers, so we are just like, I don't know, engineers finding their way through these kind of things, is that say, very, very careful with the number of buttons that we had in the interface. So we should try to have the minimum amount of buttons. And for example, like maybe there's like 2 features. Normally we just put 2 buttons for them, but then maybe one of them is actually super important. The other one is like you may do it like every once in a while. So we noticed that like we should always try to minimize the number of buttons, and the other options we should try to hide them so that it doesn't scare people away the first time they see the product. The other thing is that, along with this thing, is that we try to prototype and iterate very quickly. So our first version of this actually was built by an intern at Pinterest. So she was Lauren Mitchells. So she interned on our team like a year ago, and then she started building this project before there was like even like approved or anything. It was just like an internal kind of thing. And actually, it turned out that she did a very, very good job. And we were like, oh, actually, this can be built. Because normally it's like a big product that would be built by a big company. So it's like normally you would not think that like we should be doing it in-house. So after she proved that that it was actually possible to build this kind of thing, we continued talking with users, and they were like, oh, actually, this seems like pretty interesting. There's a lot of advantages, but we were like, oh, maybe if we try like using these like new technology things like Socket.io, etc., maybe we can make it work, even though like within a small team, so like 3 people or so overall over this time, and basically. That led us to try out new projects. So basically, we were like, let's try out. We think that we can make it work. And so basically, that's the final item. Basically, just try it out, make a very, very quick prototype, very simple version of it, roll it out with users, see the response, and then iterate from there, and decide whether or not to do it as a second step, basically.
And I'll just give a quick look at what we're working on next. So it's named Datadog, kind of reminds people of Google Docs, and a lot of people are just asking us like features from Google Doc, like auto-saving, collaboration, and stuff. So we have been thinking about our next step as being working on collaboration, and as you can see, we're trying to build a rich text editor that can let you code in the rich text editor, and also send the steps you have done in the rich text editor, so that through WebSockets to anyone who's also subscribing to this doc as well. And so that's something we're working on. And another thing we're working on is also use Celery to do query scheduling. So like you can find you can schedule any of your query in Data Hub to run at any time you want. And also, one thing we're working on right now is actually open sourcing Data Hub. We have been like migrating the code and cleaning up any dependencies, and hopefully you'll see it being open source soon. And thank you for listening to this. Any questions?
How do you democratize access to the tables and then actually have them know which tables to trust?
Yeah.
What are the interesting properties in those tables?
Totally. So yeah, that's a very good question. It's when you get like to thousands of tables and things like that, that's very important. So we first started tackling it in like an engineer perspective. Inside, like basically we run some like queries in order to gauge the trustworthiness of the data with a data quality score and data popularity score. Basically, for example, like where the data has like say alerts set up, or where the data has like tests set up, and like because we have like a Pythagoras like a system to verify the quality of data and so on. That kind of worked, so but not really. Then like say because at the end of the day we were missing a lot of signals. So right now we have that support, but it's like not really that good. So then we went with a much simpler solution. Basically, when you go into Data Hub, we didn't show that part, but like you get the list of the trustworthy tables as deemed by our official, say, data science team. So this is like say 50 or so tables with which you should be able to answer most of the most queries that you may have, at least for PMs and like analysts and kind of like these external people. So that's a very, very simple solution, but we integrated it into several parts of our tool. So basically, whenever you go into the tables, there's always like either golden tables or old tables. So that helped a lot. It's a very simple solution, but that helped a lot. What we are planning for in the future is being able to have like say endorsements, like social signals, instead like say being able to say like, hey, this person endorsed this table, and then this is the comment that they added, or this person flagged this table because they think that it's like it has an issue. So we want to move towards that, and that's our next step.
So I saw something like trustworthiness scores. What does that mean?
Yeah, so it's a composite score right now of several factors. So for example, you can imagine that it's like 10% of say where the table is has these kind of checkers, data checkers that are happening automatically. So someone had to like write a kind of unit test for data, set it up, and then that accounts for like 10% of it. Then it's like say 30% is where it's a golden table or not. Then there is like say 20% of say number of children table, like say if there's a lot of downstream consumers, it's more likely for it to be trustworthy. Then it's like say popularity in terms of like how many queries are you seeing it and so on. So it's kind of like a composite of these signals. But I mean, it got us to a closer point to where we want to be, but it's like very, very far from where it should be for it to be actually usable.
People are liking this.
No. That's a good point. So like I say, trustworthiness, we're planning or we are thinking of moving it to splitting into both popularity and quality. Because trustworthiness is difficult to like say understand. I mean, we later realized. So we want to separate like data quality that can be like measured like more objectively, and popularity, which could be like a function of also like who is promoting the table and so on.
So at the beginning of the presentation, you talked about the data flow. So I'm wondering, like, I'm assuming you do ETL.
Yeah.
So, like, how often does that happen? Is that once a day?
Yeah, I mean, most of our jobs are daily. Like, I would say probably like 90%. And then we have like some hourly jobs as well.
I'm just wondering, like, have people ever mentioned that complain about the fact that it's once a day?
Oh, yeah, definitely. Like, say, as the company has matured over time or grown over time, people before were like totally fine with having daily data. Now it's like everyone wants to have like hourly data. The reason is because, say, like if you roll out an experiment or something, and then like you have to wait for the next day in order to see the real impact. Like at this point, when we're actually now measuring revenue and those kind of things, even hours of downtime can mean a lot of dollars. So that's why now we're moving towards hourly at the very least, but also now some of the core metrics do have like say per minute kind of information.
My second question was, you mentioned you were using Qubole.
Yeah.
But are you guys using in-house clusters for Hive?
So we were using Qubole clusters. Then we moved to in-house Hive. Yeah, that's that. Okay. Cool. Thank you. So let us know if you have any questions. We'll be here. And thank you for coming here.